For this video, I wanted to show you how I usually start my night from the remote observatory. So I do everything through my VNC viewer, which is a client for the real VNC, which has a server that runs on the Raspberry Pi that's connected to the EQ6R mount. So all the equipment is there. Right now I have the guiding camera and the mount that's controlled. I don't have a camera on the telescope yet. So I will show you how I usually start my observing session in an easy way. So the first thing to do is connect to the Pi that's connected to the mount. And start K-stars. Now in this case, K-stars already runs on the Pi. It's an Astroberry. So just in case it's not up and running, this is the telescope icon that is associated with K-stars. So we just click on it and it will start K-stars. So this is what we have. I like to maximize my windows for a better view. And the second important part is basically to start Ekos and start the Indy servers. So we need to do that, and let's go to Ekos and start everything. So you can see now that it starts automatically. So I have an astrometry solver which is associated to my profile. This is very important when you create the profile. Add the astrometry there, otherwise it will not work properly. I had issues with it. If you add it, everything will be all right. And the EQ mode as well, it's up and running, and there are lots of options here. I'll come back to that. And the GPSD, which is the GPS module, connects, gets the location, the elevation, and everything automatically from the module. And then the ASI 120 monochrome mini camera, which is the guider, and this is installed on a telescope service mini guiding scope. So it came as a package, the scope and the ASI 120 camera. So everything is up and running, everything is connected. The site management, where you've got all the information about the site and also the parking options and the parking position. And this is very important if you want to park the scope. Now, there are some problems parking the scope. Usually, there are two terms that we use: home and parking position. Home position is usually the one that points to the North Pole, to Polaris. Parking position is any position that you use to park your scope, basically to leave it during at the end of the session. So it can be horizontally. In my case, it's horizontal because I have a roll-off observatory, so I cannot leave it pointing to Polaris because it will hit the roof. The roof won't close. So I usually align it horizontally, leveled on the horizon. Now we see that we have some extra tabs here. So initially we only had these three, but now that everything is connected, we have these additional options here. This is for the camera and the filter wheel. Now in my case, I have the mini camera, which is the guider. It's not the actual main camera on the scope. This is for the focuser, and this is for the EQ. EQ mount. So these are the parameters of my scope, and it tells me where it actually points. So it points to a right ascension of 10 hours and an azimuth of 6 degrees, and an altitude of 2 degrees, and a declination of 46 minutes. So this is where I parked it. So this is basically the parking position. So it's not completely flat because I use the manual commands. So I use the mount control here to bring it to this position. So I just left it like this. I didn't use, I went for a perfect 0, 0 here. We also have here the solver for solving the plate. This is very important, especially for the guiding camera. So to see where the scope is pointing. So these are the settings. So I have the field of view, focal length. So the TS mini guiding scope, it has a focal length of 180 millimeters, and it's I believe 60 or 50 millimeters in diameter. So I'm using this and to capture images and to solve them, and I also do it for the polar alignment, which is done automatically, and it's an easy thing to do. You just need to follow the instructions. Now, at the moment, let's go to the control. So 50 millimeters for the aperture, so the diameter of the lens, and this is basically what will the image will show here in real time once I start looping and capturing it continuously. So just to show you where my scope is pointing at, so on the horizon, this is north, and my scope has been parked at these coordinates here. So this is where my scope is pointing. For another interesting thing is that once you park the equipment, so the scope, and you turn it off, it remembers the parking position. So this means, and this is something that I usually do, I turn off the power to the mount, and basically then I unplug my main power supply. So I have a cable running all the way from my house to the observatory, and to avoid any issues, because the current can fluctuate, I don't have a power stabilizer, a UPS system, and to avoid any issues, I usually unplug the main cable, and when I plug it back and I turn on the scope, it remembers that it was parked. So it remembered the parking position. So to start using the scope, I first need to unpark it. Once I unpark, a good approach is to tell it to go somewhere, maybe to Polaris, and plate solve Polaris, see where it is, and if it's not polar aligned properly, you can polar align it using this tab here. And then when you're done observing, you can park again and turn off the power, unplug the cable, and it will remember because it has a buffer on the mount, some memory there that holds, it's non-volatile, it holds all the information that it requires for normal operations. Now, how do you tell it where to park? Maybe you want to change the parking position of the scope. So in that case, if you want to change the parking position, you need to go here to the INDI control, and you go to EQ mod mount and then to site management. And you see here you have the park options, and it has a current, a default, write data. So this means that it saves the data in the memory of the mount, and you also sometimes writing the data doesn't completely solves the problem, doesn't capture the new position. So you may want to purge the data first and then write the data. Use current to set up any parking position that you want, or default. Default is the one pointing north. So what I did basically, again, to set the parking position in my case, I basically use the manual controls. So these ones here, Ekos, mount control. I use these ones to bring it as close as possible to the altitude 0 and azimuth 6. So relatively flat, so that my roof can close without damaging the equipment. And once I was happy with the results, I basically went back to INDI and I told it purge existing data. I clicked purge data and then I clicked current and write data, and that was it. I am in the observatory right now. The telescope is parked. And as you can see, it's in the horizontal position, roughly. And there is a nice, somewhat clear sky. You can see Jupiter there, and it points approximately towards the North Geographic Pole. Okay, so this is how it goes. We unpark whenever we want to start our observing night. So I will unpark, and now the scope is unparked, and I have the guiding controls here. This is for manual guiding. I really don't need these because I will try to use the K-stars for guiding. So this is my setup. This is where my EQ mode is currently pointing, and I would like to go to the Polaris star. So we've got Polaris here. Just right-clicked on the on the star, and we have the EQ mode here. And go to sync aboard park. And I would like to go to here. So let's see. And it goes. Seems to be rotating nicely. And you can see it. And it's all the way to, it should point to Polaris. So the scope is unparked. It points to Polaris at the moment. So let me show you the parking operation. So it's quite easy. Now it's unparked from the mount section in Ekos. Now we just click park and it will go back to its parking position, which is horizontally in my case. Once it's parked, show only the unpark button is enabled. That's it for parking and unparking to a custom position.